So imagine you're trying to lose weight. Okay, so you're trying to lose weight and you're looking for all these tips and tricks to lose weight. And then your friend comes up, okay, and your friend's like, I read it somewhere that green tea helps in losing weight. And you're like, wow, I've never heard of that before. So just like a normal person would do, you search it on Google. And if you Google it, you'll find random blogs, ads, and even opinions, right? But since you're smarter than that, you decide to go and look for scientific papers that actually confirm your friend's statement. So you read one study saying that, so you read study 1, and study 1 says that yes, green tea does help in losing weight. But then you find another study, and now this study says that no, green tea does not help in losing weight. And now you're confused because one study says something else, another says something else. So that's basically the problem with single studies. They can be wrong, they can be too small, and even biased. So how do you go about it? What do you do about it? How do you make sense of this? So that's where systematic review comes for your rescue. Systematic reviews can fix this. And how can systematic review fix something like that? What systematic review do is they collect all the studies that are available on that specific question, and then they check the ones which are good, and then they summarize what these studies are saying. So for example, there were study 1, 2, study 3, and study 4. So there are lots of studies, right? So what systematic review does is that it gives you a summary of all the papers available on that specific question. So in simple terms, if I tell you what systematic review and meta-analysis are, so systematic review is basically, it consists, I can explain that to you in 3 steps, okay? So first step is what a systematic review does is that it finds all the studies. So find all the studies on that specific question they post, in which in this case is, does green tea help in losing weight? Okay, and after finding all the relevant studies, the second step is to check if the quality of the study is good, okay? So you want to make sure the quality of the study is good before adding them to your review, because if you're adding bad quality studies to your review, you're actually making your conclusion less reliable and inaccurate, right? And once you've checked the quality of the study, the last step is just to summarize them, right? So what you do is you summarize them into one clear answer or conclusion. Okay? So that's systematic review in the simplest terms. Okay? Now, you must be wondering that, okay, if this is systematic review, then what is a narrative review? Because I've heard it's similar to a systematic review. Now, a systematic review is similar to a narrative review, but it's also kind of different. And I'll explain how, okay? So firstly, a narrative review does not follow the step 1 of a systematic review, which is finding all the articles, because it does not find all the articles. A narrative review only includes those articles that are of interest, right? So you only include those articles that you find interesting and not all the articles that are available. And besides that, a narrative review also does not always check the quality of the studies. So no quality check, no risk of bias assessment, which introduces obviously bias in the studies. So a narrative review is like your friend telling you what you think about green tea, right? What they think about green tea after reading a few articles here and there. And they might choose the ones they like and ignore the ones they don't. And then they'll tell you the story, which is obviously helpful, but it'll be biased. While a systematic review is more like a detective work, where you follow a strict plan, like this one, like this 3-step plan, and then you look for all the evidence, not just the ones you like, but you check not the ones that you like only, okay? You include all the studies in this. And then you check the reliability, the trustworthiness of the study. So for example, you've got study 1, you got study 2, 3, 4, and then you check how trustworthy is each of the study before including them into your review. And then you summarize everything in a fair and transparent way to give you a final conclusion. Okay, so in short, if you talk about a narrative review, it's basically a review on all the articles that you find interesting to your question, while a systematic review is including everything that exists on that topic and what it all means when you put it all together. So to say, narrative reviews are good for general overview, while systematic reviews, they're best for decision making. Okay, so this is why the guideline writers, WHO, and even doctors love them, because there are around 5,000 articles published daily. And obviously it's not practical for these guideline writers, these health authorities to go through every single one of those articles. So what they do is instead they read the systematic reviews, because they're the most reliable source of information, right? And they go through them, and that's how they make their guidelines, and how they set out these guidelines and everything. And when a doctor says that this thing is proven, how do they even say that? What's the a fact behind it? So basically there's always a systematic review behind that statement that it's proven. So now let's quickly go over the evidence pyramid. So you need to understand that not all research is equal. Some types of studies give us much stronger evidence as compared to others. This is where the evidence pyramid comes in. So I'm sure you guys have seen this one before, this evidence pyramid. Think of it as a ranking system for research. So at the very bottom, we've got the case reports. Now they're useful for ideas, but they're not very strong evidence. And then above that, we've got the observational studies, such as cohorts and case control studies. They show us association, but they can still be biased, okay? And above that, then we have the randomized control trials. They are very powerful because they randomly assign people to the groups. And finally, at the very top sits the systematic review and the meta-analysis. Why? Because they combine all the studies, and then they check the quality of those studies and give us the most reliable answer possible. So that's why it sits at the very top of this ranking system. And if you're wondering about LTs are beneath the case reports right here. So that's where the LTs come. All the studies on a question, unless we have a good focused question, obviously. Otherwise, our search will be a mess and we'll find too much or too little, okay? So, and for a good systematic review, you have to start with a good question, okay? Your question must always be a good one. So now let's take a simple example, okay? Our question, let's say, is does green tea work? And that's our question, okay? And we want to know if that's a good question or a bad question, okay? That sounds fine, right? For now. But actually, it's too vague. And how do we check if it's a good question or a bad question? For that, we use something called a PICO. P-I-C-O. And what is that? So basically, PICO stands for, P stands for population. So population is who are we talking about? Like green tea works in what type of population? Like are we talking about children, adults, and whom are we talking about, right? So in this case, because we don't have a population for our question right now, let's quickly make up a population. So let's say adults with obesity. That's our population, okay? Next, I stands for intervention, okay? And what is intervention? It is what is the thing we are testing in this question. So this is the question that we have posed. So what is the thing that we are testing in this question? So obviously green tea. So green tea is our intervention for this, okay? So let's write that down. It's green tea. Next we have C, and C stands for comparison. And so comparison means compare to what? So are we comparing green tea to people who drink coffee? Or are we just comparing them to people who don't take green tea at all? So that is our comparison. So mostly what we do is for whatever the intervention is, we add a no with it. So no green tea. It's not always the case, but it's mostly the case. You can always add another comparison. For example, I could have added like coffee instead. So I'm comparing coffee with green tea, which works better to help lose weight, right? So we could have always added another one, but I'm just adding this one, okay? The control group. So that was the comparison. See, none of these things are present in my question, which just tells me that my question was very vague. It wasn't good enough because none of this was mentioned in my question already. And lastly, we have outcome. So outcome is what are we measuring? Like, does green tea work in what? In help lowering the blood pressure, in help losing weight. So in this case, we obviously had a thing in mind, which was outcomes, and the thing that we had in mind was weight loss. So we're just gonna write that down here. So putting it all together, now let's make a question. Now our question is pretty clear. So for the population, we'll start like this. So in adults with obesity, does green tea compared to, now what is the comparison group for us? Comparison group is no green tea. So does green tea compared to no green tea help? Now help, what is the outcome? Help weight loss. So help reduce weight. So that way we have a very precise question here with us, right? So see how much better that sounds? It's more focused and it's answerable. And this is a question that will guide the entire review process, right? All the search strategies will make according to this, the exclusion and inclusion criteria. So whenever you're thinking of a research question, try to fit it inside the PICO. And if you can't fit in all 4 parts, your question is probably too vague. PICO is like a checklist, basically, that turns a random thought into a researchable question. So that's how you form a question for your PICO. Okay, so now that we have a solid question, thanks to PICO, the next step is to writing a protocol, okay? So we'll write a protocol, okay? I know it sounds intimidating, the protocol thing. I'll try to make it as simple for you as possible, okay? So think of protocol as a blueprint for building your house, okay? So something like, before you even start building your house, you decide how many rooms there will be, how many doors and windows will go in there, and what material you'll use, right? So imagine, for example, if everyone just showed up and started building without a plan. Now your house would be a mess, I can assure you that, because one person might build a kitchen in the living room and someone might just skip the bathroom at all. So your protocol is something that prevents that kind of chaos. So what your protocol does is it tells your team what databases you'll use to search for the articles, for the papers. Second, it tells them what keywords to use. So in your search strategy, what words are you supposed to use? It also tells them about what studies to include or exclude. So your inclusion and your exclusion criteria as well. Oops, sorry about that. Include or exclude. And finally, how to check for their quality. What scales to use and all that. We'll talk about that in details. We actually have lectures on them and they will be uploaded very soon, so you can check them out, okay? So what's the best part is that once the blueprint is ready, everyone can work independently. And since and they'll be able to build exactly the same house. So trust me, it's not just a boring paperwork, it's your construction plan for the whole review process. So when you screen for papers, when you do the primary screening, the secondary screening, this will come in handy for you, okay? And also during the literature search. So that's the second thing, the protocol. Now that we talked about the research question and the protocol, let's move on to the first step of a systematic review, which is to find all the available studies on your question. So whatever your question is, you need to find all the available studies on that. And for that, you need to do some detective work. And what is this detective work going to be? It's going to be searching. So you're actually going to search. And before we start searching, we need to understand where we are searching, because not all the places are equal. So for example, Google and ChatGPT, basically Google is not a database, okay? And ChatGPT is also not a database, okay? Both of these are not databases. They're just search engines or the AI tools. Google actually searches the whole internet, while ChatGPT, it generates answers based on pattern it's learned. So it doesn't give you the actual research papers. So for systematic review, what we need is not random internet pages which we get from Google or ChatGPT. What we need is actual peer-reviewed research papers. And to get these peer-reviewed research papers, you need to actually search databases. Okay, because you're not going to get them on Google. So you're going to search some databases for that. And databases include like PubMed, which is the largest medical research database. And there's also others like EMBASE. Now EMBASE is similar to PubMed, but it includes more European journals and conference papers. We also have Scopus. Scopus is for broader topics. It's good for broader topics. If you're searching for broader topics, it's good for broader topics. Then we have Google Scholar, as well as Cochrane. Now, you need to at least search, it's recommended to search at least 3 databases for systematic review and meta-analysis. Okay, you need to search at least 3 of these. Don't get me wrong, Google is great if you want to find a recipe or maybe movie time of a movie, but for research we need places that store actual published studies. Okay, so that's what databases are for. Okay, so after searching, this is the searching part. Okay, but after searching, this is not the entire step, the first step. This is actually a part of the first step to find all studies. Now that you search the databases, and to search the databases, so for each database there you have to have a different search string. Okay, so it's different for PubMed. So basically, the thing that you're searching, you're not going to write your research question um, in these databases, because you're not going to get any results for that. You need actual search strategies, and for that, I think we do have a video as well. Okay, so you need to make search strategies. Okay, for PubMed, for EMBASE, there's a different one. For Scopus, there's a different one. So you need to form search strategies for this. You cannot just add your question into it and expect the database to retrieve results for you, because that's not going to happen. Okay, so after you've got your results, then, so for example, you searched all the databases. So you search PubMed, EMBASE, Scopus, and Google Scholar. Okay, and now you get like 10,000 results from these databases. Okay, so now after searching, you'll have hundreds and thousands of papers. So obviously you cannot keep all of them. You cannot keep all this big number. Okay, because this number also includes duplicates, because you're searching multiple databases, and each database and two databases can have the same article as well, obviously, right? So you remove duplicates, and that's what's called primary screening. So that's primary screening, where you remove duplicates and then you primary screen. Primary screening also includes reading abstract and title and removing all the irrelevant stuff, and you can do that using AI. You've got Arayan for that, for primary screening and secondary screening. So primary and full text, or the secondary screening. Okay, and then you read the titles and abstracts, that's the primary screening, and then you read the full text, which is called the secondary screening. And how do you remove these? What criteria do you follow? Again, you're going to follow the protocol of the study they just wrote. Okay, and then after doing all the screening and getting the last number, so for example, now you're left with, after the primary secondary screening, removing duplicates, you're now left with, for example, 70 articles. Okay, so 70 studies you're left with. You have retrieved their full text. Now what you're going to do is you're going to form a PRISMA chart, which is actually a requirement for journals, require you to submit it. It's actually just, let me show you. This is a PRISMA chart. It's actually a summary and a breakdown of how you got the articles you got. So first you identified, you screen, and which were included. So I'm going to go over it really quickly, because this video was meant to be a very short video, but it's too long already. So we can do it in another video. Okay, please let me know if you guys would like me to cover this part in detail, so we can do that. Okay, so that's the PRISMA. So this flowchart is basically called the PRISMA diagram, and it shows the readers exactly how you went from, for example, 10,000 papers down to like 70 high quality ones. So that's how you do that, and you need to submit it with your manuscript. Okay, so after that, we'll be doing data extraction. So data extraction, in simple terms, is just pulling out the key information from those studies. Things like the number of people, what they did, so the intervention, how they were given the intervention, the outcomes. So basically, just in simplest terms, data extraction. For data extraction, you have two sheets. The baseline characteristics sheet, where you write about the baseline characteristics, like what did people have before the intervention. So what were they like before the intervention, their age and everything. Okay, and then you have the outcome table, where you write the outcomes that were measured, right? So that's just the basics of the data extraction sheet. And then after the data extraction, you then also check the quality. So quality assessment. You do the quality assessment of the studies that you're including, and that's called risk of bias assessment. And for that, you use different tools and scales for that. And there are multiple scales and tools that we have discussed in our webinars earlier. So I'll upload them and you can watch them, okay? And they're in much detail, so I won't go over them. So just a quick idea that these some studies will have, let's say, so some studies are going to have very low risk of bias, okay? So low risk of bias. Some studies are going to have some concerns, and there are also going to be studies that are going to have high risk. Okay, so that's how you're going to measure them. And if most of your studies are in red, which is high risk, then your conclusion obviously becomes weaker. Right? Now, besides that, let's talk about meta-analysis. Now, meta-analysis, what is meta-analysis? We haven't talked about it yet. So, now if your studies, the studies that you're including in your a study, so if they're similar enough and you can mathematically combine them, that's called meta-analysis, basically. That's it. So just saying, I just want to explain you in the simplest terms. So in simplest terms, think of it as averaging all the results to get the best estimate. Let's make it really simple for you, okay? So for example, I want to know, does green tea help with weight loss? Now, after the extraction, after all the risk of assessment, I find 10 good studies on it. So what would a systematic review be? So systematic review would just be that I read all the 10 studies and then I check their quality. And then I write something like I write a conclusion, something like 6 studies showed green tea helps because it does still help. 3 studies showed no effect. You have to be honest, okay? And let's say 1 study showed very small effect. So that's a systematic review, okay? That's a systematic review. It's like me giving you a well-organized summary of all the studies. That is systematic review. And what would meta-analysis then be? So meta-analysis, So what a meta-analysis would be? So what if I take the actual numbers from those studies, like how many kilos people lost, and then combine them using statistics? And then I give you one final number. So you use statistics for that, right? So it's a statistical calculation. Okay? And then I give you one final number that says, for example, let's say on average, people who drank green tea lost, let's say, 2.1 kilograms more than people who didn't. Now that is meta-analysis. It's like putting all the results in a blender and then coming up with one combined answer, okay? That is what meta-analysis is. So remember, it's something most beginners actually get wrong. And what is that? That is a very important statement. I'm just going to write it in red here, okay? Now, every meta-analysis not every systematic review has a meta-analysis. Why? Because meta-analysis is a part of the systematic review. Systematic review is not a part of meta-analysis. Okay, let me emphasize on that. See, for example, we have systematic review. It is made up of A, B, C, D. Okay, A, let's say, is the finding all the articles. B is quality assessment. Let's say C is meta-analysis. Now C is obviously optional. Not all the systematic reviews, not for all the systematic reviews you're going to have meta-analysis, because sometimes the studies just don't allow, because they're not similar. So you can't really have a meta-analysis for them. So meta-analysis is an optional part of the systematic review, right? So not every systematic review has a meta-analysis, because it's part of the systematic review and it's an optional part. So not every systematic review would have it, obviously, right? But it's also important to note that every meta-analysis must come from a systematic review. Let me explain how. See, if you don't have the systematic review, how are you going to get that step, the part of it, if you don't have the main thing there, right? So you have to have a systematic review in order to have the meta-analysis. But you do not need meta-analysis in order to get the systematic review, right? You can do a systematic review without a meta-analysis. But you cannot do a meta-analysis without a systematic review. Okay? So that's that. Recap of the entire thing that we learned today. So quick recap is that first you start with a clear question using PICO, and then you write a protocol, which is your plan basically. And third, you search everywhere like crazy, all the databases. Okay, fourth is you screen and select, and then the PRISMA chart as well. Fifth, you extract the data and quality check. So you check the quality. Then you combine the results if possible, which is called meta-analysis. That is called meta-analysis. And then finally what you do is you just write the paper. So just write a clear conclusion for your paper. So that's it. That's the whole process. And that's it for the session as well. So thank you so much. If you stuck with me till the end, I hope this made systematic review and meta-analysis a little less scary and a little more clear, I guess. And since this wasn't a live session, there's no feedback form, but I'd love to hear from you in the comments. Did you like this session? Did it make sense? Drop a quick comment just to let me know, okay? And if you have any questions, you can also let me know in the comments. I'll try to answer as many as I can, okay? Thank you so much. Till next time, Allah Hafiz.